There we go. Okay, so this is lesson 7 for grade 12 essential math. This is part 2 of the quadrilaterals lesson. And I actually defined this word in our last notes because I didn't realize it was already defined in these notes. But a diagonal is a line segment that joins two non-consecutive vertices. In a quadrilateral, you could call them adjacent because they'd have to be next to each other. But if you had more than 4 sides, you could have diagonals that are more than one apart. So non-consecutive is a better way to define it. So it joins two non-consecutive corners of a polygon. And diagonals create properties in quadrilaterals. And just like we learned some properties of quadrilaterals yesterday in our lesson where we looked at their names and some of their features like how their sides relate to each other in terms of their length and stuff, now we're going to take a look at how their diagonals make them behave. First of all, we need a new definition and a new symbol. Perpendicular is a fancy word that means at a right angle. Here's the symbol, so I don't have to write this big long word anymore. It's an upside down capital T. Quick refresher from yesterday. What's that symbol mean again? Congruent. What's that symbol mean again? Parallel. We got a new one now. Perpendicular, which means hits at a right angle. Perpendicular diagonals form 4 right angles at the point where they intersect. Diagonals can blank each other and the angles of the quadrilateral, and this blank means divide in 2 equal parts. Anybody want to guess what that word is? Begins with the letter B. Bisect is the right word. Nice job. Bisect. Diagonals can bisect each other and the angles of the quadrilateral, which means cut into 2 exactly the same pieces. All right. I'm going to go through the first one, and then I'm going to pause the video and let people have a chance to try to answer the rest of them themselves, and then we'll go over it. For a rectangle, are the diagonals congruent? In other words, is this line the same length as this line? Well, notice I tell you already that that line from here to here is the same as this line from here to here. So obviously, the answer to this one's yes. Okay, now I'm kind of messing up my rectangle. Let me erase all that. Okay. Are the diagonals bisecting each other? Again, well, that kind of goes with what this symbol means. It means that the distance from here to here is the same as the distance from here to here. So, yes. Are the diagonals bisecting the angles? Well, I guess I could maybe break out a protractor and measure the angles, but I think I can kind of see it and use my imagination. This rectangle is actually almost a square. What if the rectangle is really long and skinny? Imagine that this rectangle is much skinnier. You don't have to draw this if you don't want to. But now, can you totally see that if I make a diagonal, this angle is way bigger than that angle? Like by a lot. The longer and skinnier it is, the more they'd be different. Does that make sense? So clearly the answer to this is no. The diagonals don't have to bisect the angles. Then for the last one, are the diagonals perpendicular? Which means, do they meet in the middle at right angles? Do those look like right angles to you? No. So that's a no. Now we're going to let you have a few minutes. Feel free to talk amongst yourselves, kind of argue this out. Answer the same 4 questions for the other 5 shapes. And do it in pencil in case you're wrong, and we can go over it and erase it. But that's what we're going to get the people in the room to do. So guys watching the video, pause the video. See if you can answer all the questions for all the other shapes as yes or no, and then come on back and we'll see if you're right about them. All right, we're back. So let's see what people had to say about this. Are the diagonals congruent on a rhombus? And the answer is yes. Or wait a minute. Oh, sorry, hold on. No, they're not. No, they're not. This, clearly, from here to here, is a shorter line than it is from there to there. And in fact, again, think about it this way. This rhombus here could even be flatter. Like imagine if I made it really skinny. Then clearly this is a much shorter line than that is. So the answer to this one's no, sorry. I misread my own question. That one's no. Okay, so are the diagonals congruent? No, one of them's longer and one of them's shorter. Are the diagonals bisecting each other? That's a yes. And again, they give you a hint here. They show you that that line's the same as that line. So the answer is yes, because it's true in both directions. Can I point out to you that there is kind of a mistake here, though? this line is congruent to that line. That's what they're trying to tell you. That does not mean that this distance is the same as this distance. So it should actually be, put a third tick on there so that you have a different congruence. By using 2 ticks, you're saying it's same as the other one, which isn't true. So that's a little bit of a mistake in your notes. Are the diagonals bisecting the angles? Oh, what do you think? Last time it was no. What do you think this time? This time it's yes. And I can actually convince you of that maybe a different way. Hey, this is a rhombus. What do I know about the sides? Oh, that should be there. Tick, tick. What do I know about the sides of a rhombus? Here, let me put them in blue here. What do I know about that line and that line? They're the same. Let's use the word congruent. They're congruent. So what do I know about this triangle? Well, it's the same as this triangle. So if the 2 triangles are the same, don't the angles here and here have to be the same? So yes, those lines here, and I guess here and here by the same logic, cut the angles in half. So there we go. And there. Are the diagonals perpendicular? They give you a hint in the picture. Can you see it? What does that mean again? Right angle. So yes. Now, I could say, have somebody go, well, wait a minute. That just tells me that that's a right angle. I don't know that they're all right angles. Well, think about it for a sec. Would it be possible for this to be a right angle and for this to not be a right angle? Or how about, could this not be a right angle? No. If one of them where 4 corners meet is a right angle, then they all have to be right angles. So that's a big yes. So that's the rhombus. For the square, are the diagonals congruent? Yes. Are the diagonals bisecting each other? Yes. Are the diagonals bisecting the angles? 45, 45. Yes. Are the diagonals perpendicular? There's the symbol. Yes. Isn't tight. So that one's all yes. Parallelogram. Are the diagonals congruent? No. Because again, imagine if I made this really long and skinny, right? This line here is longer than that line. Okay, so they don't have to be. The answer is, whoops, erase. The answer here is no. Are the diagonals bisecting each other? And the answer to that is yes, because again, whoops, go away. This line here is the same as that line there. Having said that, again, put a third tick on that, because this distance here is the same as this distance here, but it doesn't mean it's the same as the one going in the other direction. But they are definitely cutting each other in half. Are the diagonals bisecting the angles? What do you think of that one? That one's a no. You can even kind of tell by looking at it that that angle there is bigger than that one. So that one's a no. And are the diagonals perpendicular? Any of these look like right angles to you in there? No. Okay. So it was no, yes, no, no for that one. Yes, 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 yes for the square. And now our friend the trapezoid. Now notice that's just an everyday trapezoid. Remember yesterday we learned there was a special one called the isosceles trapezoid? This one's not isosceles. It's just any old trapezoid. What makes a trapezoid again? 2 of its lines are parallel and the other 2 aren't. So, are the diagonals congruent? They don't have to be. Are they bisecting each other? Not even close in that picture. Are they bisecting the angles? Well, it looks kind of close in the bottom, but definitely up here that angle is bigger than that one. So, nope. And are the diagonals perpendicular? Do these look like right angles to you? That one's all no's. Okay. And finally for the kite. Are the diagonals congruent? I'm going to say no, because again, imagine I made this kite really, really long and skinny compared to the one that's there. Clearly this line's way longer than that line. So no, they don't have to be the same. But do they bisect each other? Well, notice the diagram. The answer, I guess, is going to be no, and then I'll say, but one bisects the other. Right? There's one of them that's bisected. This one from here to here has been cut in half. Obviously, this one, that line's longer than that line. But one of them does, but not both of them. So make sure that makes sense to you. Are the diagonals bisecting the angles? Well, again, no, but one does, right? Can you see it? That angle there would be the same as that angle there. But notice this side is not the same as that side. So the answer is no. They don't all bisect, but one pair does. And are the diagonals perpendicular? The answer to that is yes. There's the little right angle symbol right there. So there's my rules. And just like in the last lesson, let's see if we can use those rules to answer some questions. So once again, I'll pause the video. I'll let people have some time to answer questions 1 to 4. And we'll come back together and see what we think about them in a few minutes. So guys, pause the video at home and try questions 1 to 4. All right, here is the answers. Name the quadrilaterals where the diagonals are congruent. There's 2 of them. The rectangle and the square. Name another property that's the same for both of them. For both of these, the diagonals bisect each other. So that's what would be true. Name the quadrilaterals where the diagonals are perpendicular. There's 3. The rhombus, the square, and the kite. And finally, name the quadrilaterals where the diagonals bisect the vertices. And that would be 2 of them. The rhombus and the square. So these are the kinds of questions you might see in the homework, asking you to logically think of how these rules relate the shapes to one another. Now, finally, some things that actually we're going to calculate. What do we know about this parallelogram here? ABC is 100. Okay, can I point out to you, that's not this little angle in here, it's not this little angle in here, it's both of them. Right? Follow along. A to B to C. So that's 100 degrees. Okay? They also tell us that A to B is 5, B to E. This 3 is actually only for this B to this corner here. Obviously, 3 has to be shorter than 5. So, okay, so there we go. So, how long is side CD? Any ideas? What do you think? It's 5, yeah. But how do you know that? You can't just say, well, it looks like it's the same. No, there's a rule. And it's from lesson 6. It's actually not from this lesson. This is from last lesson. What's the rule from last lesson? You would say, in a parallelogram, misspelled parallelogram. In a parallelogram, opposite sides are congruent. I don't have to write out the word congruent. Yay. Remember that? That was one of our rules from lesson 6. Now, that one I used lesson 6. This one I need to use today's lesson. How long is side D to E? So how long is it from there to there? Any ideas? Some people are putting up 3 fingers. Yes, they're right. It's 3. How do you know? What's the rule? 3, because in a parallelogram, how do I know it's 3? What's the rule that we just used? If you go back, it's actually right there in number 4. Or no, sorry, number 2. The diagonals bisect each other in a parallelogram. So the diagonals bisect each other. Okay, now for the next one, angle BCD, where's that? From here? Okay, follow along. B to C to D. So that's this whole angle here. I'd like to know how big that is. Interesting. Any ideas on how we're going to do that? This is one of those questions where it's actually easier to answer the next question first. What do I know about A to D to C? And again, this goes back to lesson 6. If you go back to the lesson 6 notes, what does it say about opposite angles in a parallelogram? They're the same. So A to D to C, that's this angle here, also has to be 100 degrees. And again, I'll say because opposite angles in a parallelogram are congruent. And now that I know that one's 100, how do I figure out how big C is? We did this again last time in lesson 6. How do we figure out how big C is? What do we know about all the angles altogether? They add up to 360. So if I take 360 and I minus the two 100s, I'll just say 2 times 100 if you're okay with that. And then what do I have to do? What would that tell me? That would tell me how much all of this and all of that is. So if I just want one of them, namely the one at C, I would divide it by 2. And you could do a little bit of simplifying. You could say that that's 360 divided by 2 is 180. And those 2's would cancel, so minus 100 is 80. And I had somebody in the other class this morning saying, oh, I actually know that in a parallelogram, consecutive angles, which again means right next to each other, are supplementary. And that's true too. So I could say that's one way to do it, or I could say in a parallelogram, consecutive angles are supplementary. And who remembers what that means from yesterday? That means they add to 180 degrees. So if this is 100, that has to be 80, which is what we got doing it the long way. That's kind of the way a lot of rules and stuff in math and geometry especially work. If you know a rule and you have it memorized, it can save you the work. Notice I had to do a bunch of calculating, but if I'd have just known that fact, then I just subtract 100 from 180. Turned out to be the same number either way. Okay. All right, that's it. Basically, the homework now is based on this kind of stuff. And you can now do, now I assigned yesterday the lesson 6 work. Hang on, I'm on the wrong page now. There we go. So I assigned that page yesterday, so now we'll give you the rest of this class to finish that one up and then do the practice lesson 7. Lesson 7 has more work in it. This one's like 2.5 pages long instead of just 1 page. So we'll give you the rest of this class. You got like 20 minutes. And then we'll give you some time tomorrow to finish it, and then we'll go over it. And then you'll have like a hand-in assignment based on this stuff tomorrow. Okay? So there we go. I'll stop my video there.